When we saw the challenge to help Victoria forecast for community evolution, our minds leapt straight to the critical period of early childhood, maybe because we were being co-opted into a game of hide and seek with a 2-year-old at the time. This led us to the question of how Victoria can prepare to meet the developmental needs of children into the future, and especially how to predict which regions will need what support the most. It's hard to capture in 3 hours, let alone 3 minutes, the importance of early childhood development. Fortunately, organisations like Harvard Centre for the Developing Child and UNICEF have put huge amounts of research and energy into doing just this, and they provide short yet powerful summaries of how early childhood is the foundation of our futures. The 3-yearly study of Australian 5-year-olds is a critical source of information on this important issue. And governments are already using the data from this census to show some interesting reflections on the current state of development across the state. But we feel more could be done to use this valuable intelligence to predict and plan to support even those children who are yet to enter the world. To start, we collected our data, downloading and cleaning up the AEDC datasets for Victoria by local government area. Then we added Victoria's population prediction dataset. And after doing some research, we decided to use the random forest machine learning algorithm and train it up to predict changes in how many children will be developmentally vulnerable across Victoria. We started by using Victoria's population prediction data, added the AEDC data, and then considered other datasets that might help improve our prediction. This included using the Australian Bureau of Statistics table builder function to access data around employment industries and local government profiles from a few years ago. Once we felt the model predicted adequately, we asked it to predict how developmental vulnerability would change in each LGA across Victoria. By including the current healthcare and social assistance workforce in these regions, we could also ask the model to predict the projected change in need for those professions in each area. Our model predicted that these 6 areas would need the most additional support staff by 2031. Using R's leaflet package, we can present these predictions in heat maps, which show clearly the areas likely to have a high need for greater support workforce in the future. All in all, we feel our random forest model shows how useful machine learning can be in linking and interpreting data to help us plan to support our communities to develop to their full potential.